thought it'd be kind of fun to show the internal workings of the belt system and how that all goes together. This is a 3D printed model, so it's not the machine parts yet. We're still having those finished up. But I left this side all buttoned up, so it's just mirrored, a lot of these parts, not all of them. When you get to the front, these two parts are individual. But these are the same, just mirrored. These are the same, mirrored. These are the same, mirrored. And they're different thicknesses. But since this is nylon plastic, it is, fairly soft. It's stiffened up quite a bit by these plates, but we wanted to prototype and, kind of rapidly iterate on design. So we've got a bunch of versions of this that, are left in the dust behind until we get it all the way dialed. So I'll just show you what's in here. So that's just a thick plate. Since it's soft and there's not a lot of material to tap into, I just added this hole. You won't see that in the final model because the machined aluminum is so rigid. But that's just to hold that steady so we can get some tests. So that's one part. This is another plate that's also mirrored here. When you go to make parts, you want to get as many of them as you can, the price goes down. But so that lies underneath, and that reveals how the belt loops through there. It's kind of confusing because it's kind of unconventional. These type of robots have existed. Josh came up with a great idea. So I'm not the designer, I'm co-designer. But, I worked out a lot of the spacing and stuff, so it's been really fun. So what happens is it's actually tied off here, and I don't have a zip tie in this yet. I made some more room in later models, and we lightweighted it and drilled out some of this. But for rapid prototyping, we just did a thick pulley there. So it's actually tied off here, and I'll just point. The belt is tied off there and goes around. That is just a smooth pulley. So it's the back of the belt that hits it. And then it goes around the drive gear. That drive gear is actually 16, I've got a little mock-up of it there, 16 tooth belt pulley. And these are 0.9 degree steppers. So the typical ones are 1.8. So twice the resolution in these guys. They're a little more expensive, but we wanted the resolution. So it goes back, loops around the pulley, and then ties off again here. And this is the tensioning device, which is kind of clever. I mean, I like it because it's hidden from the front. This is upside down, by the way. You're looking from the bottom. You can tension it here. So you can tension the belt. And it's all nice tucked away and hidden. And that slides back and forth on there. It's sandwiched in there pretty tight. Slides back and forth. That probably will be a 3D printed part on the HP Fusion Jet. I can't remember. Anyway, but these parts are cool. You can make these little parts. We've got a little nut captured, M3 nut, and that's the tensioning device. So once that's tight, you can kind of hear, probably can't hear that, but it's quite tight right now. You can kind of hear it pluck like a guitar string. Anyway, so that's how it works. So this would be stationary around the 8mm bar, like would go here. It doesn't have all of the parts on it yet, but, so it's going to pivot around that. And the way that it works is it actually pulls on this arm because this arm is all connected. I call that the elbow, the shoulder, the elbow, and the wrist. And so when you move that belt, it wants to rotate. So that's how it gets away with even moving this. You can see the belt. I don't know if you can see it, but if you hold this whole thing steady, it's going to move the belt like that. So that's how it doesn't need a drive mechanism around here. It, like your arm does, the elbow is where the work is happening here. And so the motors are essentially stationary, really. They pivot around the axis, but it's kind of neat. So it rides on a couple of 608. This isn't the final design, so those will be better captured In fact, I don't know if you can see, but I had to reinforce that with some brass because that plastic post didn't quite do the trick. So that is how it works. That's the inner workings. Now, why is this part two different parts? Why didn't we make this one part? Well, I wanted it to be able to be assembled on the desk. And if you take, I'll do it right now. There's 3 screws for the motor. These, since it's going into plastic, are Plastite screws. This funky thing designed for going into soft plastic, but they'll be M3 since it'll be going into a machine. So if that was all one part, you wouldn't be able to take this off. I mean, you wouldn't be able to put it together because this would all be one part and you'd be searching for stuff and wouldn't be able to look at the belt and everything. So it's 2 separate pieces. So that is also mirrored on the other side. And it'll hold, this one you can see it, but it'll hold an IGUS slide bearing or bushing or whatever you call it. So anyway, that's the motor mount plate. And this way you can get this all set up, loop it around your belt. And I'll show you one more time with my little mock-up here. I'll stand off to the side. There we go. So I'll hold this, and I have to pull hard to rotate it, but so that's how it works. I think it's slipping on my little screw there, but pulls the belt back and forth. So I just wanted to show you how that works, what's under the hood there, and how it's all going to go together. Again, this will be machine parts. These are prototypes, but that's how it all goes together. So pretty tight space. By the way, you'll notice these are indexed, so you know you get your motor on correctly. You'll hear it drop in there. Get your belt everywhere it wants to go. Then this is given some slack, so once that's tightened, you can tighten up the belt and it goes back together like this. Whoops, that first. And then that, and then there'll be a screw there, like you can see over here. Pretty neat.